Welcome to this tutorial on summary, post-processing and collation in Flexcom. My name is Angus Connolly. I'm the product manager for Flexcom software. In this tutorial I'm going to pick up directly from where I left off in an earlier tutorial whereby I had created a model of this steep S riser system. Then I had gone on to generate a regular wave template file in which I had used pre-processing scripting to generate a lot of different input files from a base template file. So this is a dynamic simulation. It's a master template file in which I defined parameters for wave direction and wave period. I then varied those parameters across different ranges, and I created many different input files. So you can see on the left hand side of the screen there are lots of different wave directions, and within each direction I've got lots of different keyword files, each of which corresponds to one particular combination of wave period and wave direction. In terms of post-processing, I did some very basic post-processing here just on one analysis just to illustrate what it might look like. This was created using the database post-processor. So here I'm looking at a time history of effective tension at the riser, at the vessel hang-off location there. In the next plot I'm looking at a statistical or an envelope plot of bending moment, where I look at the maximum and minimum bending moment experienced throughout the course of that regular wave excitation. We're just looking at one single simulation here for the moment. That would be done with database post-processing. So now I'd like to take a step forward from that and really start to show you how to use summary post-processing in Flexcom, which is very useful for looking at collating the results from a range of different simulations right into one central location. So rather than looking at simulations one at a time, we look at a block or a range of different time domain simulations as one coherent load case, if you like. So the first thing I'm going to do is to add a new section for summary post-processing. I can just show you the keyword format as well while I'm working on it. And I'll go into the summary post-processing and I will start adding some requests for program outputs. So the first thing I'm going to do is look for force time history, and I'm going to select the element at the very top of the riser, which is called upper catenary last. The end node of that point will correspond to the hang-off location, and I will look for effective tension. So I'll give this a title, and we'll call it effective tension. Time history. Effective tension would be fine actually. I'll just abbreviate that. I'll put some units on it. We would like to get this back in kilonewtons. I would also like to create a force envelope plot, so again mimicking what I'm doing in the database post processor. This time I'm looking at the whole riser, not just a single point on the riser, and I look for a resultant bending moment. To give that some units there of kilonewton meters. You can plot these as well via summary post processing if you like, but I normally leave these plot variables set to no because we're just interested in concise text outputs. So if we look at the keyword equivalents of those table entries, got paraforce and paraforce envelope, and these are the requests which you need to generate the summary output. So what I would normally do is I would put these requests into the template file, the master file, which would mean that all of the generated files would all have the same input requests. For the moment, just for illustrative purposes, I've just put that into one of the individual files themselves, but if you were to copy that and pop it into the master template file, it will drive all the other files for you. Just in the interest of time in the tutorial online here, I will just skip the running of that and actually just go straight to the results and show you what happens. So if I just open up one of these sample folders, I have one just that I prepared earlier here. So when you run the summary post-processing request, it's like it works the same as a database post-processing request in Flexcom. Rather than running the simulation itself again using the run button, you just use the run post-processing only to extract the results from the database. Once you do that, it produces a text file which is totally different to a plot file. Obviously it's not graphical, it's not visual, it is purely text based. The advantage of doing that is, as we'll see later on, is it's very easy to collate all this data into one spreadsheet later on using the collate function. Just to look at the results from one individual simulation, what we've got here is the max and min effective tension at the hang-off point. We also have the max and min bending moment in the riser and von Mises stress in the riser right across the whole riser system. So there's the results for one single analysis. It's a wave period of 10 seconds and a wave direction of 0 degrees. So that's what it would look like for one single analysis. The next step now is to actually collate. So if you look at these directories here, if I just type in sum just to filter the outputs, you'll see that in every direction folder I have a lot of different sum files, SUM, summary output files for individual combinations of wave heading and wave direction. Sorry, wave heading and wave period, obviously. So now I would like to collate those all into one single place. So let me do that by creating a new file, which will be just a summary collate file. It's a separate input file, but it just allows us to, rather than doing a run, it actually collates the results from a lot of different runs into one single location. So I'll create a call summary collate. I'll use metric units just for consistency because that's the units I've been using throughout my project. I'll create that file. Now I have a brand new file, and I will start to populate that. So I'll start populating with start by typing a summary collate section, and then I want to collate some information together. I will give it a title. So the title must be equal to the title which I've requested in the summary post-processing section itself. So here I've requested plots, remember, of time histories of effective tension at the vessel hangoff, and if I look at the sum file for that output, you'll note that that's exactly the same as what I've asked for. So this is one I prepared earlier, so the title may be slightly different, but the key is to make sure that you get the title of the request in summary collation exactly identical to the title of the output in the summary files themselves. So I'll do that here. Effective tension at riser top. I can give it some units, which would be kilonewtons, and I can just copy that again. And this time I will look for the bending moment. And again, I'll just go into one of my summary output files. They will all look identical in terms of how they're formatted, and I look at, say, the bending moment in the riser. So this tells Flexcom what to collate together, what information to pick out of all of these individual SUM files. That's the collate command. The next command you just need to use is a identify command, and here this lets you identify the path name to where all these individual SUM files are located. In my case, they're all in a subdirectory of the one I'm in at the moment, so all I need to type in is option equals subfolders. That means that Flexcom, when I run this summary collate file, it will search through all of these individual folders, picking out all the individual sum files and bringing the data into one central location. There are other options there as well if I wanted to. So I could use tags, as in if I just wanted to search for particular file names, like I can, if I just want to post-process the ones with 30 degrees, then I can put in a tag of 30 degrees there. I'll just correct that to uppercase. For the moment I won't bother using any search tag because I want to collate absolutely everything in the folder. So at this stage I would just run this summary collation. I won't do it now just for the sake of time in the tutorial, but what I will do is I'll open up a spreadsheet which I prepared earlier. So let's just, this is what the summary collation spreadsheet looks like when you run the simulation, and I'll just search for set tension. And you can see that it's collated all of the values from all of the different wave directions and wave periods and put them into one central spreadsheet called collate.xlx. So you can see the max and min and range, you can see which files relate to which, and if you go right down to the bottom of the spreadsheet, there's a section here called extreme values, and what this does is it's very useful. It actually pinpoints the maximum, the most critical load case combination in your simulation matrix. So for example, if we look at effective tension at the riser top, the maximum value is about 72 kilonewtons, and that happens for the wave direction of 150 degrees and the wave period of 11 seconds. So you can see how very useful this summary collation feature is for collating results from literally hundreds, if not thousands, of different simulations into one spreadsheet, and it runs very, very quickly because it's just collating data which is already available to the program from each of the individual simulations. So I'll just park the spreadsheet for the moment. I just won't save it. The next step you can do is you can actually create some 3D plots as well. So for this, I will just step back a little and go back to the simulation, the regular wave template keyword file itself, and you notice that I have put in some keywords here for summary post-processing to request attention in moment. What I also need to do here is I need to actually add another keyword here called collate axes, collate plot axis, and here you define an identifier name and a value. So I'll make an identifier for period, and I'll set the value to be the parameter that I had used earlier on, which is called t. I'll make another one for direction, and I'll set that equal to the dir parameter, which I again set earlier on. So what this actually does is, in each of these what I call summary database files, where Flexcom stores all the information, it actually, as well as storing the results, it can actually store values for the individual axes. So if we want to plot, say for example, the variation in top tension as a function of wave period and wave direction, we just need to define the axes themselves as well in the summary post-processing section. And obviously we would need to rerun the summary post-processing for all of the individual simulations, which I won't do now for the sake of efficiency. But assuming that was ran okay, and I'd now come back to my summary collate, which is my high level analysis file, I can now use a plot command as well, so I can actually plot variables of interest. So again, make sure that the name of the plot title exactly corresponds to the name of the output from the individual SUM summary output files. And here I can select the axes. So let's say the axes I want are wave period on one axis, and then the other direction, the other axis will be wave direction. Statistic is, I'm interested in, let's say, plotting the maximum tension. I could plot the mean or the min or anything really, and then I can optionally put in a plot title. So I would do that for effective tension, and then I would just simply copy all that again and put in the exact same thing for bending moment, again just making sure that my title is exactly the same as it appears in the collate keyword and the SUM files themselves. So I can just run this summary collate by pressing the run button or by right clicking on my collate file, and as soon as I do that, now there are literally hundreds of analyses here, so I won't bother doing the run itself, but I'll show you some ones that I created earlier. And let's just load this plot here. So this is a three-dimensional plot where I'm plotting effective tension at the top of the riser in kilonewtons as a function of wave period and wave direction. So you can see the plot is very useful. It's color coded. It looks quite pretty, so you can pop it into a report or whatever using the copy command. So just to recap, I suppose, in terms of what we've covered in terms of summary, post-processing and collation, we start off by defining a template keyword file, which will spawn off lots of other input files for different wave periods, wave directions, or whatever simulations you're trying to perform. As well as performing the simulations themselves, you actually request some summary output using the summary post-processing command, so you can request anything you want. When you run the summary post-processing command, it produces an SUM file for every single simulation, which looks like this. It's a text-based file. As well as requesting the outputs, you just need to define and store the variables which will act as your plot axis. So this links this particular simulation, for example, which is 10 seconds, to a 10-second results section in the database. And then finally, you go along and create a brand new keyword file, a brand new input file, which is separate to all the other ones you've created already, and it's on a high level. And you tell Flexcom what you want to collate. That results in the creation of a spreadsheet. Then you can actually request three-dimensional plots, which are the same information as it's contained in the spreadsheet, which is contained in graph form. So I think that concludes the tutorial on summary, post-processing and collation. I hope you found it useful. It's certainly a very, very, very practical tool and something that you should find helpful in terms of your day-to-day usage of Flexcom. So I hope that you can join me in further tutorials as we go forward.